So welcome guys, this is our lecture number 3. So in this lecture we will complete the basic of electric current. Electric current is a scalar quantity and type of electric current. Okay, so what is electric current actually? The direction of flow of free electrons is called electric current. Okay, the direction of free electrons or charge is called electric current. If you don't know free electrons, you can see our if you can see our previous video. We have discussed here in the previous video that what are the free electrons or valence electrons. Okay, so okay, here we can understand it easily. Here we have one copper strip, and copper strip has large number of free electrons. Okay, copper strip has large number of free electrons. Free electrons are actually the from valence electrons in a atom. In a atom inside proton and neutron, and outer side there are electrons are there. The most outer outer orbit electrons are called valence electron. Out of that valence electron, some electrons are so loosely bound, those electrons can be easily removed from the atom. Those electrons are called free electrons. Okay, so copper has large number of free electrons. Okay, and this copper strip, when voltage applied with this copper strip, okay, the free electrons started moving from negative to positive. Okay, in this direction you can see negative to positive direction. That this flow of electron is called electric current. Okay, this flow of free electrons is called electric current. Current is the flow of electrons. Actually the current is flow of electrons. Flow of which electrons? Those free electrons. Free electrons are from where? Valence electrons. Okay, valence electron. And valence electrons are which electrons? The outermost orbit electrons are valence electrons. Okay, not all the valence electrons are free electrons. The electrons are the constituent of matter. So electric current is matter in motion. Okay, so electric current is matter in motion when it's like moving. Okay, from negative to positive side, when voltage applied those to those conductor. Here that conductor is assumed one copper strip. Okay, so unit of current we have already discussed also this one. Current I is the rate of flow of electrons. We just studied this one. Current is denoted by I. I is the rate of flow of electrons. So I is equal to Q by T. Q is what? Charge. Q is charge. Okay, T is time. So unit of charge is coulomb. Okay, and T time is second. SI units all are SI unit. When Q is equal to 1 coulomb and T is 1 second. Okay, Q is 1 and T also 1. That time what will be? I is equal to 1 by 1 is equal to 1 ampere. Okay, so 1 ampere of current. So 1 ampere is of current is said to flow through a wire if at any cross section 1 coulomb of charge flows in 1 second. It means what it's saying? It's saying this is the equation. 1 ampere current is said to flow when Q is 1, means 1 coulomb of charge is uh, flowing within 1 second. Okay, so I is equal to Q by T. Q is equal to N E. N is the number of electrons, E is the charge of electron. Okay, E is equal to E is equal to minus 1.6 into 10 to the power minus 19 C coulomb. Okay, T is time. I think you know that 1 coulomb is equal to charge on 620. We have discussed already in previous video. 625 into 10 to the power 16 electron. Okay, 1 coulomb is equal to 625. So 1 coulomb is equal to 625 into 10 to the power 16 electron. Okay, so electric current is scalar quantity. Okay, here we can see, we have shown here in this picture that electric current is flowing, and we have given one direction. Here we have given direction, but still electric current is a scalar quantity, not vector quantity. Okay, electric current is scalar quantity. First look here, electric current I is equal to Q by T. Electric current I is equal to Q by T. Q is electric charge, T is time, and charge and time both are scalar. Okay, both are scalar, not vector. So electric current will be scalar, and electric current flows in a direction, but it does not obey the law of vector algebra. Okay, electric current, it flows in a direction, but it does not obey the vector of algebra. Here in this figure we can see from at first, here we don't know, we assume here we don't know how much current. Okay, at first from here we can see from O to A, this side current is 1 ampere. It's following 3 ampere current flowing through O to A, and O to B, here 4 ampere current flowing through, 4 ampere. Okay, so the total current will be 3 plus 4 7 ampere. Okay, total flow of current will be 7 from point C. So here it will be 7 ampere. Okay, here 4 ampere. So we can directly add these 2 ampere, and we can say from C point 7 ampere is coming. Okay, we are not calculating any degree, whatever degree it is here. We just we don't need to know, and that means we can say it does not depend on the angle. Okay, 7 ampere total. We can just sum both the currents, and we can say total current is 7 ampere coming from point C. So type of electric current, we'll normally hear like it's only 2 type. One is AC, one is DC. Okay, one is AC and one is DC. type of electrons, but it actually 3 types. Okay, actually 3 types. One is steady, one is varying, one is alternating. Steady one is called DC. Alternating one is AC, and one normal varying. Okay, varying current. Steady current or DC current, varying current, and alternating current or AC current. Okay, so in DC or steady state current, what magnitude does not change with time. Magnitude or current does not change with time. Here we can say, here xyz, here in this x t time, in y direction I current. Okay, here you can see the graph of steady current. This one is steady or DC current. There is no change in magnitude. Okay, no change in magnitude of this current. So this one is steady or DC current. And varying current, magnitude change with time. Magnitude change with time. Okay, magnitude change with time. Here we can see in x direction t and y direction I. From 0 point, this current is following, it's changing. Here you can see it's changing with time. Okay, suppose at this point, if you don't understand it's changing or not, it's just changing. Okay, it's changing with time increasing, and it's changing. It's not fixed. Here it's totally fixed with time. Whatever time it is, current value is, suppose if it is 0.1, 0 to 1, all in all position it's 1. Suppose this one is 1, this one is 0.9, suppose, or 0.8. Here current value is, suppose time is here t1, t2. Here we can say we can give any t1, t2, but all t1 time, at t1 time also current is that 1, at t2 time also current is 1. Here you can say at t1 time current is 0.8, but t2 time current is 1. Okay, so it's changing with time. Magnitude of current is changing with time. And the number 3 is alternating or AC current. Okay, magnitude change continuously with time and direction change periodically. Okay, magnitude change with time, but along with that direction also change, and periodically it changed periodically. Here we can say from starting from 0 it starts flow of current is flowing. Look, it's making sinusoidal wave. Okay, direction will be like that. Okay, and there is this one is one full circle. Okay, here at t by 2 second it's one half circle. Okay, t by 2, total time is t. Here we can say it's t by 4, here t by 2, here t by 3, 3t by 4, and here t. So I think you guys understand. If you have any doubts, you can comment in the comment box. Thanks guys for coming to this channel. I hope you will subscribe this channel, so that later if I upload any videos, and I will be uploading so many videos on basic electric. We are going to complete total basic electric. Okay, so thank you guys, bye bye.